Hello everyone. In this video we will do some examples in which we combine different integration techniques with partial fraction decomposition to find an integral. Let us start with this one. When you look at this integral, well, it seems big and huge, but you need to see a point here that in the denominator we can write everything in terms of x cubed. And what is even better is that, so x cubed here is like that the derivative of x cubed, which is 3x squared, is in the numerator. So that tells me that use substitution, and what's set u to be x cubed. As a result, du is going to be 3x squared dx. So what we have in the numerator together with dx is our du, and I can easily now transfer this integral to u integral. So this will be u squared plus 3u plus 2, and then this du. Now I have just the rational function. The numerator has degree less than the denominator, so that means that we can start and do the partial fraction. So here I will write it in this part. So I have u squared minus 3u plus 2. I can decompose it to, let me write up here, u squared plus 3u plus 2 is, well, what are two numbers that when we add we get 3, and when you multiply you get 2. That is 2 and 3. And since these are linear factors and they are unique, so our decomposition will get this form. Linear in the denominator, while there will be constants that we need to find those ones. So here let's just find the common denominator. These are the things that we have been learning about. So u plus 2 plus b times u plus 1. So by this work here, now we can conclude that 1 is equal to a plus bu plus 2a plus 1b. Yes. So two polynomials are same polynomials in u, so that means that the corresponding coefficients must be equal. There is no u on the left hand side, that means the coefficient of u on the left hand side is 0. On the right hand side, however, it is a plus b. On the left hand side the constant is 1, on the right hand side it is 2a plus b. And we have to solve this system. Yes, so here I can see that a must be negative of b, and then plug it in there, so we get minus 2b plus b must be equal to 1, and from there that is minus b is 1, which gives us b should be negative 1. Now that I have what is b, I can put back into that equation and find that a should be 1. Yeah. Okay. So we can come here and see what are the numbers here now. So I decompose this as a, which is 1 over u plus 1 du, plus b, which is negative 1, so I'll take the negative out, and then u plus 2 d. And this gives me, well, ln of absolute value of u plus 1, that's ln of absolute value of u plus 2, then plus c. And actually we can use properties of ln and write this as u plus 1 over u plus 2 plus c. we are not done. Remember that at the beginning we did substitution. Now we have to plug in back our original variable, which was x. So for u, we plug in x cubed. And that is what we have. So one step substitution, then we got to the point that we can use partial fraction decomposition and go from there. Okay, let's do another example here. Okay. Well, again, so we are dealing with an integral which in first look it seems strange. It's just going almost nowhere. But if you check a little bit carefully, you notice that the denominator, we can write it, everything in the denominator as powers of e to the power x. And when it comes to the numerator, actually the derivative of e to the power x, which is e to the power x itself, appears there. So that tells me that use u substitution and set u to be e to the power x, then du is going to be just e to the power x dx. So this guy here then will give me du, and my integral can be easily turned into 4u cubed minus u dE. Nice. Now I have a rational function. The degree of the numerator is less than degree of the denominator. So we can go ahead and try to factor the denominator and find the partial fraction decomposition. So this I want to factor. I take out the u there, so this will give us 4u squared minus 1. I can go a little bit more. I can do this 2u plus 1 and 2u minus 1. So as you see, these are linear factors without any repetition or any power. So that tells me that the decomposition, the partial fraction decomposition, must be of the form u in the denominator, 2u plus 1 and 2u minus 1, and well, we will get different constants up there. Yeah. So now find the common denominator. Well, there we'll multiply and get what we have there. But here when we multiply, the first one is going to be 4u squared minus 1 times a, plus the second one is going to be b times 2u squared minus u. Yes. And the third one is going to be c times 2u squared plus u. Okay. And then I just rearrange the numerator so that all the powers of u, the same powers, are together. So here you see I have 1u squared. There is 1u and there is one constant. Okay. So for u squared, the first one is going to give me 4a. The second one is going to give me 2b. And the third one, I need a little bit more space here. Yes. Sorry, 4a plus 2b and then plus 2c. Plus the coefficient of u, the second one and the third one has it, and it is c minus b. What about the constant? There's only one constant, and that's a. And in the denominator, if you multiply, you get the same denominator as our original one, but I'll keep it like that. So this implies that my numerators must be equal. But numerator are two polynomial. This guy, the coefficient on the right hand side, coefficient of u squared, is that piece there, but on the left hand side there is none. So that means that 0 must be equal to 4a plus 2b plus 2c. on the right hand side there is a u, and the coefficient of that is c minus b. On the left hand side there is none, so that means that this must be 0. On the left hand side, on the right hand side there's a constant term negative a, and on the right hand side that is just 1. So from here we conclude that a must be negative 1. From this we conclude that c and b must be equal, and if we plug in these two into the first equation, what we will get is that minus 4 plus 2b plus 2c must be equal to 0. And result of that, I can go a little bit further here. Well, I can, instead of c I can put b as well. So I get 4b equals to 4, which gives me b is equal to 1. And right away from the equation that we found before, c must be as well 1. So it's b, which is 1. So we found all the coefficients here. A must be negative 1, b must be 1, and c must be 1. So I can write the decomposition now here for myself. Minus 1 over u du. The second one is 1 over 2u plus 1 du. And the third one is 1 over 2u minus 1 du. So now we are down to the partial fraction. Integrals of these guys are easy. Remember that integral of 1 over, so maybe I write it somewhere just to recall what we have. Integral of 1 over ax plus b dx is 1 over a ln of absolute value of ax plus b. Well, we are assuming that a is non-zero there. So here that will apply, and I will get half of ln of 2u plus 1. And the third one is as well half of ln of 2u minus 1. And then plus c. Here then we can use the properties of ln. For example, you see this halves can go in and give us square root, and then some you add them, you multiply. This is the same thing, so this could be like 2u plus 1 times 2u minus 1. And then there is absolute value of u, but the negative sign, that means that that could go downstairs. Or in other words, let me just make a little bit better that one. So this will be 4u squared minus 1 over u. And we are almost done. Remember that we started with a substitution. Now we have to plug in back our original function. So e to the power 2x minus 1 over e to the power x plus c. So that way we combine this substitution and integration with partial fraction decomposition and found these two integrals.